All right, guys, let's take a look at our next problem. Okay, so the problem is saying solve the following equation, and it seems to be following the format m dx plus n dy equals 0. And we know that this is the format an exact equation takes. And so we're going to solve this using the exact equation method. However, you should be aware of the fact that there's another equation that takes on the same format, and that is a homogeneous equation. So first, a homogeneous equation and an exact equation take on the same exact format, and so that makes things a little confusing. The good news is we have a way to quickly check whether this equation is exact or not, and I showed you earlier a quick way to check whether an equation is homogeneous or not. So we're going to start by seeing whether or not this is exact, and if it is, we're going to solve this problem using two different methods. We're going to start with the way your book kind of does it, and some teachers like to teach. And then I'm going to show you guys a nice little trick that we can apply on this type of a problem that may make things a little bit simpler and less convoluted. But first, let's see if it is in fact exact or not. So here are the steps in solving an exact equation. The very first thing is that you have to make sure that it is in the right format, m dx plus, and not minus, plus n dy equals 0. So since our equation fits the format, we can proceed on to step 2, which is to check whether this is in fact exact. In order to do that, we want to take the derivative of the first function, the derivative or the partial derivative of m, not with x, but rather with y. So if we do that, if we take the derivative of this function with respect to y, there is no y's here, so that's a constant. It'll be 0. Over here, the derivative would be 4e to the 2x plus 3y. And then since we're doing this with respect to y, that 3 will come down, and that'll give us a final answer of negative 12e to the 2x plus 3y. Similarly, you also want to take the derivative of n, not with y, but rather with x. And as long as these two derivatives are the same, it's going to be an exact equation, and then you can follow the procedure for solving exact equations. So over here, remember an exponential stays exactly as it is. This time I will multiply by the coefficient of x in the exponent, or 2, and I will realize that this equation is in fact exact. So we can say that since the derivative of m with respect to y, these two things mean the same, they're just different ways of writing the same thing, is the derivative of n with respect to x, therefore this equation is exact. So we're going to start by following the procedure that you guys are used to doing if you studied from the book, and that is to first of all integrate the first piece over here with respect to x. Once we get our answer, there's going to be some constant that is going to be a function of y that's going to be allowed to have y's in it. Then we're going to derive our answer with respect to y and make it equal to n in an effort to solve for that constant. Once we have that, we're going to plug it back in and get our answer. Even though it's fairly easy if you've practiced this, there's a much simpler way to solve this problem, as we will see in a minute. Okay, now that we've discovered that this is exact, we can take this and put it away. Well, I'll just put it right here. And we'll solve the rest of the problem right here. So the first thing we're going to do, we're going to say that the derivative of m with respect to, the derivative of our answer, the derivative of f with respect to x is equal to m. So using this, we're going to integrate this piece to solve for f. So we're going to say, let's say fx, or f rather, we'll call it f1, since we're using the first method, is going to be the integral of 2x minus 4e to the 2x plus 3y. And we're going to integrate this with respect to x. So if we do this, it is fairly straightforward. This is going to become 2x squared over 2. The 2's will cancel. And integrating e, well, you recopy it. But then you have to divide by the coefficient of x. And then we'll have some constant, which we know can be a function of y. So simplifying this very quickly, we get x squared minus 2e to the 2x plus 3y plus some constant, which is a function of y. And that is the first piece of our answer. Now the next thing we're going to do over here, I'm just going to get rid of this, we don't need it, is we're going to say so the next step of the process is to take df by dy and make it equal to n. So currently, this is what we have for f. This formula is saying, take the derivative of this with respect to y and make it equal to n, which is this guy right here. So let's do that. If we derive this with respect to y, what do we get? Well, here the 3 will come down. You're going to get negative 6e to the 2x plus 3y. And if I derive this with respect to y, I'll simply get c prime of y. I'm going to make this equal to n, which is this piece here. So staring at this for a few seconds, you're going to realize that these guys cancel out. And in order to solve for c, I mean, if the derivative of c is equal to this, then c would be the integral of this piece here. And hopefully this is simple enough for us to just do in our heads. If we were to integrate this, we would add 1 to the power here. It would become y cubed divided by 3, which would cancel with this 3. So c is simply y cubed. All that remains is to take this and plug it back in here, and then write out your final answer. So our final answer for this particular problem would simply be x squared minus 2e to the 2x plus 3y plus c of y, which we've just discovered to be y cubed. And in an exact equation, you always make this equal to c. So that is the answer to this problem applying the book's method. Once again, let's go over the steps very quickly. Step 1, ensure this is exact by taking the derivative of m with y and making sure that it is equal to the derivative of n with respect to x, not y. Before you do this, of course, you have to make sure that the equation is in the right format, m dx plus n dy equals 0. Once that is done, you're going to essentially apply these two formulas. The derivative of f with x is m, and the derivative of f with y is n. So doing this, essentially take this first piece, integrate, get an answer. Take its derivative with respect to y, make it equal to this, and solve for c. Take your c and plug it back in. So those are the steps. Not that bad. It is manageable. However, there's a much quicker way of solving this problem. Let's take a look at our way of doing it. Now, our way of doing it uses the exact two same formulas here. df by dx equals m, and df by dy equals n. We're using essentially the same formulas, except what we're going to do is we're going to integrate each one of these two pieces on their own. So just like we integrated this first piece, that step will stay the same, but instead of taking derivatives and making it equal to n, we will also equate this second piece. And then I'll show you, integrate this second piece, and then I'll show you how to come up with the answer like that. So for us, it's going to be a 3-line problem. So step number 1, integrate this first piece, 2x minus 4. So we're going to say, let's say fx is equal to the integral of 2x minus 4e to the 2x plus 3y. We'll get that answer. And here I'm going to say fy is going to be the integral of the second piece of the equation, which is 3y squared minus 6e to the 2x plus 3y. And we'll integrate this with respect to y. So we integrate the first and the second. Let's write our answers down. Over here, we would get x squared minus 2e to the 2x plus 3y plus some constant that's allowed to have y's in it. And over here, we would get y cubed minus 2e to the 2x plus 3y, plus some other constant that's allowed to have x's in it. So hopefully you guys can see what we're doing here. We're simply integrating the first piece and the second piece separately. And at this stage, guys, we're done. We're ready to write our answer down. I just have to show you how to do it. So when it comes to writing down our final answer, we're going to start with the first answer that we have here. So x squared minus 2e to the 2x plus 3y. We'll ignore the c. Remember, our answer always is equal to c, so that'll encapsulate those two guys. So this is my first answer. Now I move to the second one, and I simply slap on every piece that I don't already have. So, y cubed. Do I have a y cubed here already? Nope, so I'm going to slap that on. Next piece, minus 2e to the 2x plus 3y. Do I already have that? I do, so I don't tack it on a second time. And that is it, folks. This is our answer. And notice that it's equivalent to this one. Done in a much more simpler fashion. I hope you would agree. You can solve every exact equation this way. It'll always get you to the same answer. Hopefully that was helpful. The one question, guys, that I get a lot over here is, what would you do if, this number were different? Let's say this is minus 2x, and let's say this is positive 2x. What would you do in that case? Well, my answer to you is double check your work, because you've for sure done something wrong. Okay? It'll never happen that you have the same two functions that differ in their coefficients. All right, guys, let's move on to our next problem.